Harry, that we have almost 300 people. Wow, that's a lot.
No,
yeah,
we broadcast to all Indonesia, So our Zoom facility can be accommodate 300 participants.
Yeah.
If more than that, we should shift to the other one in 1,000.
Yeah, because Dr. Harry is the chairman of the Indonesian Road Association construction. So I think it's very easy for Dr. Harry to, to take participants.
Thank you, Pak Wayan.
Yeah,
Yes, thank you. Introduce me. I chair of the Road Association of Jakarta area. So easy to me to broadcast to all our members, Mr. Cho. Especially for free of charge.
Hello. Zoom meeting.
Bapak Wayan.
May not lah.
Halo.
Oh.
Saya lihat ada beberapa teman ini di sini.
Bapak Wayan.
Ya, Pak Yayan, apa kabar Pak? Ketemu lagi.
Saya dengar kabar tentang pajak ya di Medan, Pak ya.
Iya betul, about kira-kira 2 bulan lalu ya, 2 bulan lalu, 3 bulan lalu mengalami kecelakaan itu. Tapi udah baik sih sekarang.
Udah baik, alhamdulillah.
Sorry, just now was knocked out. I don't know what that.
Sudah kan? Tapi kan?
So Professor Chu, you are off today, yeah?
No. I'm working. But if you want to arrange a physical, I can take leave and come to Jakarta. But since you did not, I come to office.
Oh, I see.
It's okay.
But the semester is already
Finished.
It's finished, right?
Yeah. I was busy making 200 examination script last week. So last week was very bad.
You mean your student is 200?
Yeah, I have different classes. Total is about 200. Yeah.
They will keep you busy to grade the exam.
All right. So that's why you tell me Monday. I say, hey, Monday I want to sleep. Yesterday I want to sleep. I just finished by yesterday. Actually, finished marking by yesterday. Oh. So I want to sleep afternoon. So today I'm fresh. Today I can whole day.
Okay. So yeah, this webinar will take 2 hours.
No problem. Yeah.
So sorry about too late. Maybe in Singapore now it's 4 o'clock, right?
Oh no, normal. I can talk for 4 to about 5:30 if I try to control my time, and then leave some time for some questioning at the back.
Sure. Yeah.
But you know me, if you don't stop me, I'll talk for another 4 hours. You know?
No, definitely I will stop you. Dr. Harry will stop you.
Jadi, Wayan, sudah pukul 3, apakah mau kita mulai atau masih menunggu?
Kalau saya Pak Profesor sudah di sini, saya dari sini. Kalau dari kami sudah Pak, bisa mulai. Pak Heri kan juga sudah, teman-teman.
Ya.
Kan?
Knockout. Professor Wayan, before start, let me introduce 2 very important person. One is Mr. Tan. I think you met him last time. In the
yeah, Mr. Tan, right?
Yeah, he owned the dynamic machine. Yeah, so he's more than happy to support and ship to Indonesia.
Yeah, good afternoon, Mr. Tan. Nice to see you again here, even though it's in
webinar
online. So nice to meet you.
Yeah.
Yeah. Good afternoon.
Good. Now, then we also have another gentleman. Let me see, is he still there? With this, Marcel, are you still there?
Yes, I'm still here.
Marcel, Mr. Marcel. Yeah, Marcel is actually one of the director of Ornament in Holland. And we say this is a good collaboration between us and Holland all these years. And he's so grateful that he's in Singapore. So I also asked him to join.
Okay, thank you, Professor Chu. Nice to meet you, Mr. Marcel.
Yeah, nice meeting you too. And thank you for your invitation to join this. Looking forward to it, Professor Chu and Professor Wayan.
Sure, yeah. Silakan Pak Heri, Pak Adib.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Bapak Ibu yang kami hormati,
Waalaikumsalam warahmatullahi wabarakatuh.
Good day, everyone. Welcome to the webinar on rapid dynamic testing method, which is widely used in geotechnical engineering to determine performance and load capacity of piles. As your moderator, my name is Adib. I'm from DG of Highways. I would like to get you through the agenda and ensure that you have an informative and engaging experience. The agenda is the first one. We will have a welcome speech by Dr. Engineer Heri Fasa. He is Ketua DPD HPJI Jakarta and Ketua Satgas IKN Bina Marga, Chairman of IRDA, and the head of IKN New Capital Task Force. And then we will have an opening from Prof. Wayan Sengara. He is a professor in civil engineering and geotechnical expert from Institute of Technology Bandung. And then we will have Prof. Chu, which will deliver the dynamic and rapid new loading method for pilot test. He is an assistant professor in the Department of Civil Engineering, National University of Singapore. And then we will have question and answers, and then we will have a closing. But we encourage you to participate actively in the Q&A session and take advantage of this opportunity to learn from our expert speaker. Before we start the agenda, let us hear the Indonesian anthem and followed by IRDA March. Pak Fahri, silakan. Indonesia Raya.
Indonesia tanah air, tanah tumpah darah. Di sanalah aku berdiri, jadi mandu hidup. Indonesia kebangsaanku, bangsa yang tanah airku. Marilah kita bersatu, Indonesia bersatu. Hiduplah tanahku, hiduplah negeriku, bangsaku, rakyatku semuanya. Bangunlah
Terima kasih. Kita sudah dengarkan bersama lagu Indonesia Raya dan Masa PJI. Namun sebelum ke pembuka, before we opening remarks from Dr. Heri, we would like to thank to our sponsor. Sponsor acara hari ini ada dari Hutama Karya, Wika, Wijaya Karya, kemudian Pembangunan Perumahan, Jaya Konstruksi, Nindya Karya, Waskita, dan Modern. Kemudian ada juga dari Adikarya dan Wika Beton. Terima kasih kami sampaikan kepada para sponsor yang sudah mendukung pelanggarannya webinar ini. Baik, acara selanjutnya adalah opening speech dari Chairman of IRDA DKI Jakarta. Please, Miss Dr. Heri Fasa. Silakan, Bapak. Silakan Bapak Heri Fasa.
Masih mute mungkin ya. Pak Heri masih mute, Pak.
Saya telepon Mas Adib, saya teleponnya ya.
Oke, Dim, suara saya dengar?
Bapak? Sudah keluar sekarang.
Oke, thank you. I lost my button. Thank you very much. Good afternoon. My name is Heri Paza. I am a chairman of Road Association for Regional of Jakarta, and also now as a chief of the group team to accelerate development road in new Indonesian capital city in Kalimantan. Thank you to join us in this webinar. Now the participant already reached 85. Yeah? We plan to have about 300 members to join in this webinar. I think as the opening, I would like to address the key factor of the pilot foundation in design. In this occasion, I would like to thank to Pak Wayan and also Mr. Chow and Mr. Tang, and as well as Mr. Marcel. If I not forget, Marcel from the Netherlands. Is it right, Marcel? Yeah,
that's correct.
Yeah, I have a friend of mine in Netherlands when we developed our PDA test. Mr. Peter Middendorf, maybe you know him. Yeah, we back to 1985. Yeah, we brought a diagnostic system from TNO from Netherlands.
Yeah, well, we've met at that time, I suppose. Peter's my friend, see him every day.
Peter Middendorf.
Yep, still in the company.
In some company?
In our company.
Yes.
Oh, in your company.
Yeah.
Yes, Henry, the Ornamic, Peter Middendorf and Marcel, they are the same company. They see each other every day.
Good. Okay. So in 1995, we brought the PDA test from TNO. Yeah, so we learned more diagnostic of the condition from the TNO. Yeah, I was in that bed in 1985. Thank you. I'll say hello to Mr. Middendorf. Yeah. So in pilot foundation, in my experience, the problem is how to install the pilot foundation. Yeah, especially for the bridge. Yeah. The bridge in Indonesia commonly is not easy to access. Yeah. So we should think about how to mobilize the foundation, the pile foundation, as simple as possible. Once we have a foundation, pile foundation chosen, then the problem again come to the what kind of the devices we need to drive it. Yeah, we don't have a big pile driving at the time. Yeah, so that all the condition should be burned on the mind. Eh? Then after that, we also think about how to determine the pile bearing capacity. Eh? Again, for this case, in case of the road bridge sometime crossing the river. So we should think how to test. If we test by the ordinary testing method, such as static loading test, then we came to the issue how to have a reaction pile or cantilever. After that, if it is a too big pile, so also we came to the problem how to test it. How to make sure the capacity of the foundation. All the thing is an issue that could be addressed during we design of the bridge, especially for bridge crossing the big river. Yeah? We have introduced many kind of testing method. Yeah? Static loading test is commonly used, and again in 1992 we have know about the whip equation. Then at that time we have introduced by the PDA and dynamic loading test. Then we interest to use the product from the TNO. So this system is quite simple to us to use in the field of the road bridge. Yeah? Especially a road bridge crossing the river. And then after that, we also have introduced and know by the TN also about the statnamic. Yeah, statnamic. Once have been done in Surabaya, I think, back to 2000. Yeah, we have a big seaport, use the bore pile and then tested by the dynamic loading test. Now we have used for the big foundation, tested by using the bidirectional testing method, or we can call this the OSIP test. Yeah? But again, the precise to define the location of the sensor is will be determine the quality of the testing result. Again, also we should be delayed maybe about 30 days, because of the foundation should become hardened before we can test it. Yeah. So I think today, Mr. Cho and Wayan, Pak Wayan, and then Mr. Marcel would like to introduce to us the new method of the foundation. So I think we will take a patient and then to try to keep all the introduction from him, and probably that can be make the advantage to us to use in Indonesia, especially in shortcoming project that we will finish in next 2 years. Thank you very much. Enjoy the seminar and have the benefit from the webinar. Thank you very much.
Thank you, Pak Heri. Thank you, Dr. Heri, for the welcoming speech. Agenda selanjutnya, next agenda, we will have an opening lecture from Prof. Engineer Iwayan Tengara. He is geotechnical engineer from Institute Teknologi Bandung. His PhD, Doctor of Philosophy, is from University of Wisconsin, USA, and then Master of Science from Engineering Mechanics, University of Wisconsin as well, and then Master of Science in Civil Engineering, University of Wisconsin, and he was a bachelor degree in Civil Engineering Department, Institute Teknologi Bandung. Right now, he was geotechnical engineer for PT Lapi ITB and member of the DKI Jakarta tim penilai ahli. And please, Prof. Wayan Singara, the place is yours. Thank you.
Okay, thank you, Pak Adib. Thank you, Pak Herifasa, and thank you for all the participants for joining this webinar. Particularly, I would like to thank again Professor Chu, Mr. Marcel, and Mr. Tan for contributing to this webinar. So I just would like to give some introduction or just a brief requirement on the load test for bridge, particularly in Indonesia in this webinar. So basically, what we would like to have is what is the requirement of the bridge foundation for the design and the construction of the bridges. So we have foundation loading. In this case, for the foundation loading, we have need to provide the bearing capacity of the foundation, and also the second one will be the integrity of the construction. So we have our own national standard, particularly for geotechnical engineering in general, but some of the requirement is also applicable or valid for several structures such as buildings and also bridge. In Indonesia, usually we refer the national standard to international standards, such as, for example, for bridge, we refer to American Association for State Highway official, and also for building some other like international building codes, and also, of course, the American standard for testing material. While the purpose of that is to verify the bearing capacity of the foundation to the design load, and also to verify the design parameter that we use, so that our foundation has been according to the calculation, and so that the design is acceptable. So we have QA, QC, quality assurance, and quality control for the foundation. And the second one is again for the integrity of the part. The load test is usually it's very common. Well, not actually very common, but some of designer propose to the owner. Usually we could do preliminary pilot tests, verifying the design parameter, result of the soil investigation data that we use for predicting the bearing capacity, and also for the purpose of optimization, we could do preliminary load test. We could do it from the static, PDA, whatever. We could do that. While during construction, so this is the requirement for the production piles. So we have the requirement, let's say, like 1% of the production pile need to be tested. So for the load test, we refer to SNI 8460 2017. So this is actually the geotechnical requirement. Where within the geotechnical requirement, we have the particularly the specific for the pile foundation requirement. So this is the list. I think I saw it. So you can find this in SNI geotechnic. What is the minimum factor for safety for the design? What is the tolerable settlement? What type of loading combination and support, the lateral capacity? What is the requirement? And the last one is the pile test. What is the number of the pile test? Whether it's axial, static, lateral, and tension, and also whether static or dynamic. For the load test, we have the axial requirement, axial compression, axial tension, and lateral. The PDA, pile driving analyzer test, is allowed actually in our codes, our standard, but it's limited to like in Jakarta, for example, for building is limited to 25% only. 20% of the total static load test could be replaced by the PDA, So this has been proposed last time by the Authority Committee of Jakarta, but I think also the SNI of geotechnical SNI also refer to that. Even now a lot of 40%. So I think this is too many. A lot of 40% of the total static load test could be replaced by PDA. So I think today's webinar would like to evaluate this requirement, and if we would like to be more stringent, like what conducted in Singapore, for example, Europe, United States, and also in Japan, for example, there is a limit number of PDA, but with more number of static or equivalent static, like maybe what we will discuss today, step dynamic or step rapid load test. Okay, this is just another requirement. We need to do 200% of the design load. We can do more than 200%, but usually the requirement is 200%, and also with the maximum displacement allowed for the acceptance of the pile load test. Well, if we refer to S-stop, for example, for the particular brake design, we have this requirement for driven pile and also for bore pile, and the number of load tests is actually not stated clearly, but every different in zone we need to have at least one static load test, and for dynamic test minimum 2% of production pile need to be tested, but I think for the common practice in Indonesia we refer to the SNI, and then we need to have 1% to 0.75 or 1.3%, 1 to 1.3% need to be statically load tested. So this is the detail of that. So I think this is just for information on our case in Indonesia. Juga untuk rekan-rekan kita di HPJI untuk pengembangan jalan atau desain jalan, kita tesnya harus memenuhi requirement ini kan gitu ya Pak ya. Itu untuk melihat saja kembali. I have experience to review the Chinese code for a project of the high-speed railway that from Jakarta to Bandung that has many elevated structure, and then this is the comparison of the Chinese and the SNI. Basically, the requirement is not too much different. We have static load test requirement, and also the PDA is not stated clearly. So, but what is more stringent in the Chinese code is the integrity test. So all of the bore pile particularly need to be cross-sonic lodging tested. So this is part of the pile integrity test. Well, Pak Heri already mentioned about the another option in Indonesia. I think it's quite well, not quite new. We have that bidirectional static load test conducted. Let's like in Suramadu Bridge, as far as I can remember, last time the bidirectional static load test was conducted, performed at the time. I think some PDA also. Well, again, I agree with Harry. The problem with this is, so we need to locate the cell. So there is a theoretical interpretation of this test, so that the unit skin friction at the upper part need to be equal to the units the skin friction at the bottom, with additional the bearing and bearing capacity of the pile, which is actually we cannot determine yet, but we need to somehow decide that. So we have experience on conducting this load test in Jakarta for super high-rise building, well, a proposed super high-rise building, but not yet constructed right now. So to 9,000 tons, this is very long pile, up to 110 meters below the ground. So this is very difficult to determine the location of the load cell. So this is just our recommendation. But actually the task of the contractor proposed this, and the location was at that particular location, and we are not sure whether the mobilized friction at the top and also mobilized friction at the bottom plus the end bearing is in equilibrium or not. So the limitation of this kind of test would be, well, need to theoretically determine the level of the shells. Some of the end bearing or skin friction might not be fully mobilized. And also relatively complicated. The instrumentation takes some time, we need to wait for the hardening of the concrete. And also here is the last time what we identify is the load inclination issue for high pressure load, particularly for high pressure load. And also there's some issue on the interpretation on load system. Well, this is a new method in Indonesia, even though in other countries we have this pilot test has been conducted for many years in US, Europe, and also in Singapore. This is the slide from Dr. Chu. Actually, we have a dynamic test like a PDA, and then we have a static load test, and then we have rapid load test, including stat dynamic and stat rapid test. This will be presented by Professor Chu in detail later on. And for information to all of us, this stat rapid and also stat dynamic has been included in the ASTM standard D7A7383. And also referred in the Euro code in 2016. So for internationally, this test has been commonly conducted.
Yes.
But here in Indonesia, I think we need to promote this, and I believe later on Dr. Chu could provide with a lot of information, and almost maybe also test case for that. Let me conclude that some notes, some recommendations here. I think our coach SNI and also in ASTO has provided the QA/QC for the construction for the production pile. That's we are in Indonesia already in line with the international standard for that. And also, well, in Indonesia, in our SNI now, the PDA has been allowed from 25% to 40% of the static load test can be replaced by PDA. So, from my personal opinion, because PDA is not too reliable test actually. So, allowance for this 25 to 40% might need to be evaluated in the future for the QA/QC test. But this PDA test could be conducted, but mainly for the integrity of the test, not for the bearing capacity of the piles. The stat dynamic and stat rapid has been in the STM and the Euro code, and has been make it equivalent to static load test. So this is a good opportunity to apply it in Indonesia. Later on, maybe the SNI need to be evaluated further, because the stat dynamic and stat rapid is more reliable compared to PDA. So that is some of the items, or some of the things that we need to identify. For I think hopefully this item can be can be useful for discussion later on after the Professor Chu presentation. Thank you, Pak Adib. Thank you, Pak Heri. So that's the end of my presentation.
Okay, thank you, Prof. Wayan Sengara. Terima kasih atas paparan pembuka dari Prof. Wayan. Namun sebelum kami mulai, before we go to Professor Chu, I would like to thank again to our sponsor. Our sponsor is we have from Utama Karya, and then Wika Wijaya Karya, Pembangunan Perumahan, PT Pembangunan Perumahan, PT Jaya Konstruksi, PT Nindya Karya, PT Waskita Karya, PT Modern, PT Virama Karya, PT Wika Beton, dan PT Adikarya. And now we will have the main keynotes from Professor Xu. Professor Xu is Dr. Chu Sun Hu, is a professional engineer, PhD from the University of California at Berkeley, USA. He is currently an assistant professor with the Department of Civil Engineering, National University of Singapore. He is currently the Director of Safety Study Initiative in US. His teaching and research interests include geosynthetics, slope engineering, land reclamation, soil improvement, deep excavation in soft soils, numerical modeling in geotechnical engineering, rapid and dynamic payload testing, erosion control and ABC water features design, geophysical method in site investigation, and geological engineering. He is actively involved in research and consultancy relating to this aspect of geotechnical engineering. He was elected to be a council member of the Institution of Engineers Singapore, IAS 2006 to 2011, and re-elected for 2011 to 2013, and then until 2018 terms. He is currently the president of Southeast Asia chapter of International Geosynthetic Society, IGS, and president of Singapore section of the American Society of Civil Engineering, ASCE. Okay, now we will have Prof. Q. Time is yours, Professor Q.
Okay. Good afternoon. Thank you, moderator Adib, for the kind introduction. And thank you, Dr. Harry Vasa, for kind introduction on your power testing or power design in Indonesia, and Professor Wayan for your nice introduction on the testing, especially the code requirement in Indonesia. I think that's a good education to me. By the way, can everybody hear me clear and loud?
Yes.
Okay. I love to do face-to-face, more interactive lectures. So yes, understand this is a webinar, but still I will talk. But anytime you have question, you can just voice it and then we can discuss, right? If it's too big a problem, too big a question, I will leave it to the end. But please, welcome to interact and stop me anytime. And then if I speak too fast, certain thing you want me to elaborate, just voice it out, okay? I will try to make about 2-3 stops in between to ask you for comment or question. Please respond, huh? Okay, everybody there?
Yeah.
Good. Okay, so this is a good opportunity for me to share this, and I realized that Henry, you're familiar with TNO. TNO is defense-related organization in Holland, and they are the one who developed this method, stagnamic and stagnamic. All right.
Oh yeah, thank you.
Yeah, and you know Peter, you're going to see his picture later on. Yes, these are to do with Peter. Yes, so very good. Okay, so the title for this afternoon is stagnamic and stack rapid. These are two methods. We call it rapid load test, which I explained. This is a new loading method for power load test, and I'm happy for Professor Wayan to mention to sorry, who is someone has to turn off your mic. Someone have to turn off the mic. Yeah, okay, good. So these two methods, as Professor Wayan say, is a new method that has been well accepted by America, ASTM, and Eurocode. So in fact, when I was in the States, there are a few states like California and Georgia State and Arizona, they use it quite a lot. Okay, but it's popular use in Japan as well, and in Europe, and now of course we are proud to say that it's very popularly used in Malaysia and Singapore. And we see the similarity between our rock and soil in Malaysia, Singapore, and Indonesia. So I'm confident that this can be a great help to Indonesia. Okay. Now, so I'm going to share about a few things. Number one, what is this test and what's useful for that? So need for the change from static. By the way, I should say very clear that this method is not to replace PDA, but actually to aim to replace or substitute static load test, right? It's aimed to really to replace, that's what we do in Singapore, replace the static load test, okay? And therefore is fit into the static load test category rather than the dynamic load test, which I'll explain to you in a short while. Number two, I will explain about theory and how to interpret the result. In short, I will say that this interpretation is a lot more reliable, accurate, user independent than PDA. I'm sure we all know PDA very easy to conduct the test. Dr. Henry was asking me equipment wise, how do I compare with PDA, that kind of thing. In short, we all know, as what Professor Wayan also say, PDA is easy to conduct, but the interpretation of the result is actually subject to a lot of variation. In fact, I also support PDA tests in Malaysia, Singapore. PDA has what, 15, 16 parameters that you can change, match the result. So sometimes the result you get is not really representing what actually in the field, okay? But on the other hand, I would say that rapid load test, the method I'm going to introduce, actually is very consistent. The interpretation is very straightforward and give the result is very accurate as compared to static load test. So I'll explain that in a short while. And then I will say a little bit about codes, ASTM code, particularly important, and European codes. I'll say briefly, and some other detail, you want to know more, we can have a second talk next time, okay? Then I will jump on to section 4, which is talking about correlation with static test. I must convince you that the result of this rapid load test is equivalent, is equal to static load test. So therefore, you can use it with confidence. That's my duty to convince you in a short while, okay? And of course, finally, I want to say that this rapid load test is very useful. Why? Because it will help your productivity. In Singapore, Malaysia, it improved our construction productivity greatly. I'll show you the numbers in Singapore. And I'm sure when you build a new capital city, you're in the, fast track, you have many things to do. You do not want your Palo test to be the on the critical path, right? You want the Palo test to be able to do quick, fast, and get over it so you can do more important things, okay? So that's called productivity gain, which I'll talk about. Okay, so that's the scope. Everybody still there? Yes? Marcel, yes. You still there? Huh? Okay, good. Now, so let me being a professor in university, so we always like to go back to very, very basic and fundamental. Okay, so what is Palo test for? Palo tests are needed for one or more of these four. Number one, to determine the bearing capacity of the pile, which I'm sure you all agree. So we want to know what is the ultimate bearing capacity. Number two, which is very important, which I saw in your Indonesian code, you also have it. To determine the settlement of the pile when it's subject to N time. N can be 1.5 or N can be 2 times equal to 2 times of the working load, right? And we want to know that when pile is subject to this, what is the settlement? Now, I will share Singapore, Malaysia experience on this because we built a lot of high-rise building. I'm sure your capital also. When you have a high-rise building, the settlement control become very, 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 very important because you cannot have a high-rise building that's tilting. You cannot have a high-rise building that have differential settlement, which is very dangerous. So therefore, in Singapore, Malaysia, we have very strict control on this, and that's where this rapid load test will be very, very useful. Okay. Now, number three, of course, related to number one, is we do determine the soil parameters used in your pile design. And this is, for example, I think in Indonesia, you call it preliminary pile load test. I'm sure you have this to verify your shaft friction and you verify your unit end bearing. So from here, you check your calculation. Okay, so that is yes to verify. And rapid load test can do. And you use the same strain gauges design as what you do in the normal static load test. So there's no difference. The only difference is the way you apply the load is different. So that's number 3. And number 4. Number 4 related to number 2, which is very important, as what Professor Wayan just also highlight. We need to ensure the quality of power are well constructed. And that we can do only at a proof load test, meaning that you construct 100 piles, the engineer has to randomly select the piles after constructed, randomly, to check whether this pile pass your criterion. And I'm sure your Indonesia code, just now I quickly saw the number that Professor Wayan showed. Yes, it is there. All right, you need to do this 1% or 2%. You need to do 1% of the number of piles to do this what we call proof load test. And in this proof load test, you cannot pre-select. You cannot pre-select, meaning that you cannot pre-select. You must construct the pile first, then you run the test. Okay. Now, of course, so therefore that means that bi-direction test is not suitable, because bi-direction test, you need to pre-select the pile, you put the jack inside, and then you construct, which is not fair, because by doing that, the contractor knows you're going to test this pile. So they will make sure the piles are very well constructed, which may not be the same as the other piles that may not be selected, right? So therefore, this is not good for proof load test, okay? But of course, a lot of people will do PDA test, which is okay, like what I said just now, except that the interpretation of result is a lot of problem, especially when you're ball pile. When your ball pile, your dimension, your the diameter or the cross section of the pile is not going to be uniform, and the concrete quality is not going to be the same, especially a long pile. I saw that your pile is 80-90 meters. It's not going to be uniform. So therefore, your PDA interpretation is a big question. Okay. Now, good news is with all these 4, you'll find that rapid load test fit very, very well. Okay? Now, of course, traditionally we use the cartilage block. Okay, cartilage block we can see on the left-hand side. This is a cartilage block. Now, and then you also do what called steel plate. So the steel plate will save the height. The cartilage block, the steel plate will have a less height, but still the total amount is, the weight is the same. And then this is the kind of combination of the two. I mean, this is a traditional method. It's a good method. It's a good method, except that you need a lot of this. You need a lot of this. Okay. So I'm not saying this is not a good method. This is a very good method. Sometimes we do what I call reaction power method. But of course, the problem for reaction power method, you need money to construct this 4 additional powers. Okay. Of course, there are some people use the other production power to use as a reaction power, which in Singapore normally we don't accept, because by the time you put it, the behavior is different from if you function it as a real normal power. So yep, so you construct additional reaction power. This need time and also need money, extra money. Okay, now there's also one aspect that not many people are aware of, which is if you do a test power here, actually you need to have a clear distance between the test power and the footing of your cartilage block or your steel block. You need this clear distance. Now, not many people are aware that actually this clear distance in the old day in ASTM is only 1.5 meter or like that. But today, actually, this is 2.5 to 3 times of diameter of the power. So if your diameter is 1.5 meter, your 3 times of diameter is going to be 4.5 meter. So therefore, you should have 4.5 meter here, and then another 4.5 plus 1.5. So actually, this distance from here to here is going to be 10 to 20 meter, which is or 17, 18 meter, which is going to be very wide. So to support this wide area, firstly, you need to have this area, wide area. You occupy a lot of space in your construction site. Number 2, to support that, your girder, your beam design will have to be very careful. Okay. Now, so therefore, that is sometimes people may overlook this. You need to have a wide span. If not, if you put it too close, the stress bulk of this fella is going to unfairly make your power look too strong. You understand my point? If your distance is not big enough, the stress bulb here, applied here, then will make this part, the test part, too strong, artificially too strong, which is not right. So therefore, this is some expect that some people were misunderstood, right? Minimum spacing, 3D, whichever is greater. And I summarize different code of different country, different code. As I say, ASTM long time ago is 1.5. That is because at that time, all the parts are very small. But actually today, you look at ASTM, we are, look at all the later one is actually 3D, 5D, 4D. You see, a lot of these are going to 3 times the diameter of the part. So therefore, you really need a big span. Anyway, so all this will lead up to the problem I mentioned here. It takes long time to set up and also need test, and also high transport cost, because by the time you construct what should I say, transport all this block, you need to run on the road, so that carbon footprint, okay, to some country like Singapore, we are concerned of that now. European, large space required, and you need labor intensive. Okay, of course, Indonesia, you may your labor cost may be very reasonable, but down the road, I'm sure your labor is also expensive down the road. In short, low productivity. So we want to improve on that. Now, more important is safety. So let me show you this. And maybe let me show you a video. Right, this happened in Singapore, and you can see the cartilage block actually. Okay. Okay, can you guys see the video? Did you guys see the video? Can someone respond to me?
Yeah, yes, you can see your video.
But although it's kind of move frame by frame, but you see, right? You see the whole issue, huh? Okay, I don't need to repeat, huh? The whole issue is this cartilage, this whole block actually can fail. So that is a safety issue. And the higher you go, the more dangerous you are. And the power that Professor Wayan showed to me or discussed with me, you're going to test for 1,006 tons. It's going to be very high. So safety is a big issue. Now you actually on the internet, you can find a lot of this. This in Singapore, this in China. You can find the picture speak for itself. Huh? So you stack the cartilage block. Actually, there's always danger of this safety. So now that's the reason why in Singapore, right? Singapore Building and Construction Authority, Singapore. A few years ago, we start to recommend, instead of doing this for high one, we change to building smarter. So therefore, we go to what we call rapid load test. Now, so advantage of rapid load test, let me summarize first. Rapid load test, reduce the setting up time. I'll show you very fast to set up one day. Limited space requirement, I'll talk to you about this. And less transporting, because you don't need to carry that much of concrete blocks or steel plate. I'll show you. And the result is correlate very well with static load test. This is very important. So in short, and of course, it's accepted in ASTM and Eurocode and Japan code. High productivity. Okay. So I summarize to my words. Okay. Safe, fast, small space, and technically sound and accurate. Now, so I want to summarize this forward. You remember, So rapid load test is safe, fast, small space required, and technically sound and technically accurate. This is important. As a professor, of course, this is important. The result is important. Okay, and that's what we call the rapid load test. Okay, so that's a kind of give you a quick overview, introduction. Okay, before I tell you what is that method. Okay, let me make a break. 30-second break. So far, everybody okay? Can hear me clear? Any immediate question? Please ask if there is.
Yes, very clear. Bapak Ibu, silakan kalau ada pertanyaan.
Okay.
If you have question, please raise your hand or.
Mr. Chu.
Yeah, continue. Okay, good. Okay, let me sip a water. Good. Okay, now go to part 2. Very important, the theory. So I'm going to share with the concept I'm going to share with how the basic feature and how to interpret to get to the good result. That is important. Now we're all engineers, so we need that reliable and good result. Okay. Now, beautiful cartoon. Okay, all this picture started with Peter. Okay, actually the whole idea is Sir Isaac Newton. We all know who is this guy. Actually, he observed that the apple will drop, and then we all know this theory. Apple will drop is because of gravity. Okay, and the force of this dropping force is equal to m, which is the mass, times the acceleration, isn't it? And the acceleration, of course, we all know here is gravity, g. So therefore, in a very simple term, if you have 1 pound, you guys familiar with US system, if the mass is pound, 1 pound of apple will produce 1 pound force. This is force. In US, they have this unit called pound force, easy to understand. All right, but today, of course, if it's 1 kilogram of apple will produce 1 kilogram 0.9.81, which is 9.81 Newton, which is equal to 0.009 kilonewton, like that, 0.09, yeah, correct, kilonewton. So yeah, basically, whatever mass produce whatever force. But you ask yourself, what if the acceleration is 20 g? What if this A equal to 20 times of g? All right, so therefore 1 pound, sorry, I'm using green, I hope y'all can see. 1 pound of apple will produce 20 pound force now. Can you see that? Instead of 1, I can produce 20 pound force now. So 1 kilogram of mass will produce 20 times, 1 kilogram times 20 times 9.81. So we produce 20 times of the equivalent mass of force. So therefore, very good. You see that? Now let me stop here. Remember just now we said static load test. You need to stack up all the concrete block. Very heavy. Now I can reduce that by 20 times. 1 over 20. Reduce it by 20 times. So if you need 1,000 test load, I only need 50 tons instead of 1,000 tons of concrete blocks. So that's very beautiful. That's the whole idea. Okay, so that's Newton's law. But at the same time, we also need what we call this guy, second guy. Just now this one is a few hundred years ago guy, Newton, a few hundred years ago guy. But I also need a young man, 21st century man, to make the machine. So therefore, together, this is under TNO. During the TNO time, right, Peter worked with some of this Peter, Patrick, all this, to develop a machine that you can blow up, zoom, go up 20 times of g, acceleration equal to 20 of g, and this force moving upward is equal to force moving downward. So the force here is m times 20 g. So there's a big force pushing downward. So that is the stagnamic. So that is the one called stagnamic. Stagnamic is not an English word. It's static plus dynamic. And then they combine together, become stagnamic. Static plus dynamic. So that's how they create this word, stagnamic. Okay? Stagnamic. Okay? Okay. Yep. Stagnamic. Okay? So that is what Peter have done and with the gang and wait, where's my move? Yep. Now, so what they have to do is you make a machine like this. This is a machine that they make. Okay. Inside that, there's a white color. This is a mass. Mass is equal to 1 over 20 times of the test load. So if the test load is 1,000 tons, I only need this equal to 50 tons. Can you see that? Very little, 50 tons versus test load of 1,000 tons. Okay, I'm mixing the unit of mass and force. You know what I mean? Equivalent. Okay, so if you need 1,000 tons to test, I only need 50 tons of the weight. Okay, now you need a special thing which is here, which is a special chamber, which I put a special fuel in this confined chamber, and then later on, you have a gaseous expansion, expand very rapidly, and that will produce a large uplift force, and this uplift force will push the power downward. Can you see that? This force will push the power downward. That is the Harlow test. That is the force that pushing the power down, and then you measure it. That's it. So that's simple. Okay, you can skip this one. Now I talk about this fuel. People may get worried. What is this fuel? Actually, this fuel is something like this. This is a fuel. Okay. Now and then you will light it up. Don't worry. This is not explosive. Not the C4 explosive. Actually, this is something like that. When you burn it, I have a video. I don't know whether it work or not. Let me try. When you light it with a secret lighter, right? You jam a little bit. You see, you can still hold it. Okay. Can you see the video? Yes, right?
Yes.
Hello? Yeah, okay. So you can see that actually no danger. It's just hot. Hold it hot. But if you put in a confined chamber, the volume expand very fast, and using the physics, Boyle's law, whatever, you will push up the whole, you push up this thing, you'll push up this whole thing, and the force will come down. That's it. Very simple mechanism that was developed by TNO at that time, and Peter was one of the key members. Okay, and yes, I think the company that I support technically, Mr. Tan and Marcel company, they can do this test for you. But after, and then these are some of the tests you can see. Maybe I can skip this, or maybe I can skip this test. Or do you want to see this one? Maybe I see this one, This video okay, I think it's coming up. Yeah. The video shaking is because the guy holding the camera is next to the Malaysia Railroad. Watch out. See that? Okay, you see the loud voice, Okay, the thing boom, go up and push apart. That's it. Just now, Professor Dr. Henry was asking me how long will it take the test? That's all the test. Set up, maybe take one day. When you test, that's over. That's it. Okay, so we have done a lot. Just show you some of the some examples. This is very limited example that I show you. We have done a lot. A lot means in a number of hundreds, if not thousands, in the last 20 years in Malaysia and Singapore. Okay, but the famous one, Penang Second Bridge, Singapore, Malaysia do the next to train track. In Singapore, the port development, we do it a few times. And of course, I said yesterday, that was last time. In some of the big housing development project. Oh, sorry, what am I doing? Oh, this is, no, I can skip this one. Yeah, so in housing development, HDB block, housing development block of Singapore, I think you all know, actually they do a lot of this test. Why? Because they have a lot of high-rise building to build in a short time, and they need to test all of them. Using static test is going to take too long, and a lot of times a contractor may cut corners, right? So therefore, rapid load test, after I introduce to them, very happy, and we use a lot of it, okay? These are the engineers, officer to talk, and a happy face, and these are the results. Now, I just want to show you, yeah, this is the result that you get immediately. When you run the test, boom, millisecond, 100 or 200 milliseconds, so like this. Then you get a result on the screen. This picture is a load. This is a load. And this is a time. So go up and come down. This is load. And this is a displacement settlement. You can settle, of course, is the other way around. Settle and come back. So this is settlement. And this is a time. And then this is the velocity. This is acceleration. So you get all these results on the screen. That's it. Over. Technically, you know whether the test pass or fail. But of course, you let the company go back 1-2 days to compile the report and send to you. But basically, you know the result on the spot. You know the result on the spot. Okay. Some of it may concern about vibration. We also monitor vibration. And in fact, you'll find that all the vibration is well within the, of course, within 10 meters is big, but further than 10 meters is nothing. It's well within all the construction limit. In fact, I published together with Peter a paper on vibration in Japan.
Sopan ya Allah. Pak lihat Pak. Parah Pak.
We can skip this. This is the picture when you show you. This is expensive equipment here, but this is the mass, and the chamber is inside here, and the power is below here. Power is here, and then you can just run the test. I'll show you this one later on. Now I want to show this one because I know that you guys are doing breaches. In case you do breaches across river or across the sea, see, this is the power you want to test. Right? I can put the whole dynamic on top of it because this only 1/20 is 5% of the test, so very small. And then run the test, and that's it. I don't need to do, if you are doing static test, you need to have additional auxiliary power to put the platform and then put a concrete block like this, and then you do the jack and test it here, and then test it here. So this is additional supporting power. Right, in marine, this is going to spend a lot of money. Can you see that? So this supplement is not needed here. Can you see? I can put the whole thing on the power to be tested. That's it. All right, and we have done quite a lot of these tests in Malaysia, both in Western Malaysia and Sabah, Sarawak. So Sarawak is just north of your capital city. Same big island. What's the name? What's the island name? Kalimantan. Big island there. So we've done a lot of tests in Sarawak there on this test, across the breaches across the river. So that is something very useful. Okay. Okay, so now that was the first method which I introduced a concept. But the really method I will introduce is who is this? Henry, can recognize this man. He's none other than your good friend Peter. Okay, and his team is Ornamic, which we worked together in the last almost 20 years now. Okay, so Peter, after Marcel, I hope what I say is correct. After he's about to retire from TNO, he said, hey, I'm going to invent a new method for my own company. So he developed a stack rapid method. Stack dynamic belong to TNO, and then they sell to somebody else. That's a separate issue. But now Peter developed a stack rapid method. So stack rapid method, he don't play with fuel anymore, but instead he play with a special cushion. So you're going to drop a mass, which you can call hammer, but I don't like to call hammer. I like to call it drop mass. It's special drop mass. Put on something special cushion. I draw here, but actually it's a very special cushion. When you drop on that, this cushion was subject to compression and will generate a deceleration of 20 times of G. A equal to minus deceleration of 20 times of G. So therefore, it produces the same force. Minus means the direction. So now the force is directly applied onto the power. So the magnitude is mass times 20 times of G. That is a force. It's the same as dynamic now, but except that now force is downward because of producing that deceleration and causing the power to push the power down. Now that's it. So that's called stack rapid. And of course, the name tell you is the same newly created English word. Is static plus rapid load test. So put together stack rapid. So therefore, it will give you a long duration load. And you can see from these pictures, the yellow color is a mass. You can call it or drop mass or whatever you call it. Right. And then there's a cushion here. It's a special cushion. I'll show you secretly a little bit. This thing will do this a drop height. So this thing will drop onto that and produce a force. Right. This cushion is different. It's not the PDA cushion. PDA cushion is to protect the power top only. It cannot perform the function of decelerating or whatever. Whether this cushion, the special cushion, will produce the A equal to minus 20 G. That is the secret. This cushion have to produce that deceleration. Okay, now these are secret pictures. I'm showing you the cushion. It can compress like this, and then you will bounce back. Okay, and then do I quickly show? So in short, I will put the cushion here and then drop mass hit onto it, and that will give you the force. Okay, now let me show you the real run. Okay, this is interesting run. Okay, let me show you. Yep, I hope you can see it because this is important. Okay, I stop here first. Let me bring this away. How do I bring this away? I cross out it. Okay. You can still hear me, huh? Okay, you can see this yellow color thing is the mesh. All right, there's a gap here. There's a height, huh? Of course, this height not much, but there's a height. Cushion is at the bottom. You can see and the power is below. Okay. Now, in a few seconds, I'm going to turn on the video. You can see that this yellow color will drop, hit the cushion, and then bounce up. Okay, so watch carefully, huh? Okay, coming up. You see that? Yellow cushion was here and drop and come back. See that? That's done. Over. And there's no big leak voice. Huh? So it's very smooth, very gentleman, very gentle. Very nice, right?
Oh, pernah aku ikutin.
Everybody see that? Everybody see? Right.
Yes.
Yeah. Okay, I'll show you one more time. Okay, but this time very fast, huh? At the very beginning. Okay, I show you one more time. This one is a different one, but it's the same. Huh? See? Let me repeat this one. This one at the beginning. Okay, see? The yellow one is here. There's a gap here. Gap at the middle. Huh? The blue color, you don't see. The power, this one you can see the power. The power at the bottom. You can see there's a reflective white strip here. Later, I'll talk about that. That is the one to measure settlement very fast using laser beam. Then on top is a load cell. It's a standard load cell will measure the actual force. Okay, so you can see, very fast. This yellow thing is going to drop, hit onto the cushion, produce a deceleration. The force will load onto the power and then bounce up. When they bounce up, this machine can also catch on it. Once you catch on it, you can move to a different height and repeat the test. All right, so this machine can catch it and then move to different height, drop again, and bounce again, catch it, drop again. Okay, now you see, very fast. See? Okay, it drop and then it bounce a little bit and then it catch. Okay? See the power is here?
Like hammer.
Look like hammer, but the trick here is not so much on the hammer, it's a cushion and also able to catch it. It's able to catch it. Okay, look like hammer, yeah, but it's more than a hammer. The normal hammer, if you don't have the right cushion, don't have the proper design, it can't work. So you need this frame to support it as well. Now, this frame, I should explain a little bit of this frame. This frame is very well designed because this hammer is going to drop free fall. You cannot friction around. So therefore, this blue frame must be perfectly vertical. So this, I should commend Peter and his team, Marcel. They designed this equipment such that it can be, you have to level, if the thing tilted, it cannot run. You have to position it perfectly straight. There's a lot of sensor here to be checked, to make sure this whole frame is straight. You press the button, boom, run, finish. Okay, that's beautiful. Okay, there are many projects were done again. If not many hundred, in fact close to 1,000. Okay, I think video work, so I don't need. Now this picture is showing you one of the many projects done in Singapore. Right, and then I like this picture to show you what is the size of the rapid load test. You see, only this small. Compared with this one, this is still in the making, will come up here. But even this size is much bigger than this. So of course, if your space is big, you have no problem. But sometimes in some project, the parts are very close by. So it's easier to mobilize this. By the way, this comes from 2 containers. These 2 fit inside here. This is a 20-foot container, 2 of them. All these things fit inside here and take out and assemble it up on the side. That's it. So you only have to transport these 2 containers. That's all. Okay. So in comparison with this amount of block, you can see so many block and so many steel plate, all this, all that. All right. So that saves a lot of time. Again, it's the same. The other project, again, the same. Can you see that? These 2 containers will support all these come from inside. This empty now. All this fit inside. Okay. They pack it very nicely. Just nice, pack inside. But you look at this, still have a lot to do. And also you can see in the ground is very difficult ground. This one can do. Imagine even to do the static last year, you have to level the whole place. I mean, there's a lot of things you have to prepare. Whether for this case, no, you just will make sure that this thing can stand flat. So you prepare the ground a little bit, can stand flat. And the dimension of this, I'll show you later on. It can be as small as 3 meter by 3 meter to at the most 6 meter by 6 meter. Very small. And whether this one, remember we said just now, this can be 10 to 18 to 20 meter by 20 meters. So all this can be very wide spacing. So you see the difference between the two. In city area, particularly in Singapore, Malaysia, this makes a lot of difference. All right, because a lot of sites are very congested. You really need to have this kind of thing. This is just a picture showing very small Singapore, this airport. Everybody know this small Singapore red dot, and yet we have done so many. This is only partial. In fact, we have more. Okay, so now let me come to a very important aspect: interpretation. When you get a test result, remember just now we say you get a test result like this. This is a load. This is a time, and then you also have the result of settlement, do like this and bounce back. So this is time. All right, this settlement, this load. So we have these two results plus velocity plus acceleration, right, of the power. What can interpret? Remember, what we want is what is a static capacity. What do you have? This is rapid load test. Rapid load test is not dynamic, but a little bit of dynamic. All right. So how do I get this into a static equivalent? That's what we want. Okay. Let me repeat. Rapid load test has a little bit of dynamic component. How do I interpret such that I get a static equivalent? Sometimes I lecture, I forget how to spell simple word. Equivalent. Okay, static equivalent. How do I get my static equivalent? Okay. Okay, so we can skip all this. Okay, come to equation. So this is equation of motion. Simple equation of motion. This is a mass of power now. We're talking about power now. A power like this, I have a mass drop, hit onto it, okay, and produce that deceleration. Anyway, there's a force here applied. So therefore, this power will move. So when you move, there's an acceleration, there's a velocity, there's a displacement. U is a displacement, which is settlement, okay? K times U is the static force that we want. Static capacity we want. But now we have these two additional components. And the left-hand side is the rapid load that you measure. You measure exactly by the load cell. So therefore, what you have to do is very simple. I want the static force. I just have to equal to rapid load test minus the MA minus the CV. That's it. Minus away these two. That's all. Okay, so this is just explaining, but end up with the same answer. Never mind this. At the end, this is okay. This just explain using soil parameter. But never mind that. Eventually, end of this simple equation. Just on the 2-3 slide, explain in terms of soil parameter, but doesn't matter. At the end is rapid load test minus MA minus CV. Okay, V is the velocity of the power. A is average acceleration of the power. Right? And then this is the mass of power. All these are measured because I'll show the instrument later on. You put an accelerometer on top, similar to PDA, but more accurate than PDA. And then from there, you get acceleration. From there, you integrate, you can get a velocity. And you know the mass of power. And you measure this by load cell. Measure by load cell. Right? So the only thing you do not know is C. Okay, the only thing we know is a damping coefficient. Damping, that is something we do not know. We can make some simple assumption if you want, then whole thing can be solved. Okay, so let me show you. So that's exactly what I mean. Okay, I think Professor Yan also borrowed this picture and show you. All right, let me summarize this again before I go too far. So the static test, you need 100% dead weight. If you want to test 1,000 tons, now the mass here have to be equal to 1,000 tons. Of course, I'm mixing the unit now, but you know what I mean, equivalent, okay, to test it. PDA, you are very small. Drop mass is 1 to 2% of test load, of load, small hammer, brick. You measure the signal and do signal matching. Actually, you do not, your acceleration, but you do not measure load. You do not measure load. Whether static, you measure load cell here, and also rapid load. Rapid load have two types, dynamic and stack rapid. Okay. Hyperdynamic is Japan name, never mind this. So the same, you measure load cell blue color. You also measure settlement. You also measure settlement by laser beam, So therefore, you direct measure power load and power settlement, same as static. Different from PDA. That's a major difference. So there's no curve fitting needed. There's no 16 parameter no need. There's only one parameter, which I'm going to show you how to fit. Okay, so this is what you get. Remember, just like I said that when you run the test, you basically measure. Okay, why should I do this? I don't need to do this. You measure the load, measure the settlement, right? Which is what you have here. I don't know why I do this. Never mind. Yeah, you measure the load with time. You measure the settlement with time, the red and the blue line. And then for this point, I have the load Q1 and settlement 1. So I can plot the value Q1, and this is delta 1. So I can plot this value. So actually, from these two data, I can get this curve. So this is the load settlement curve, except this is under the rapid load test. Okay. Now, of course, you can see this curve. When the load increase, the settlement increase. But then you will come to a point that settlement is the maximum, which is here. This is maximum settlement point. After maximum settlement point, the power actually bounce upward. Right? If you look at my illustration, the power was go down when you load and bounce back. Go down and bounce back. At the bottom, before the power come back, the velocity here equal to 0 because velocity downward is positive, upward is negative. From positive to negative, there's a 0 in between. So velocity equal to 0. Remember the formula just now? Static equal to force rapid load test minus MA minus CV. If this velocity equal to 0, CV equal to 0. So I don't need to know C. I only need to measure rapid load test and measure M and A. I get a result. So therefore, I do that. See, this value is MA. I subtract or plus, depending on acceleration. Acceleration can be negative. So minus MA become plus the value of MA. Minus or plus, doesn't matter. Okay. So it become here. So therefore, this is the accurate static force. And let me say this. When you come to this state, there's no assumption made. I mean, the only assumption made is, okay, rapid load test valid for this power. Okay, which we'll talk about later on. Related to the duration of load, we'll talk about later on. But basically, there's no complicated curve fitting equation. No, straight away, this is an accurate point. Okay, that's it. But unfortunately, one cycle, only one accurate point. If I don't know the others, right, which is this equivalent static curve, the other, I need to assume C value. Assume C value from this point and this point, I can calculate C value, which is not too bad. After get a C value, I get this whole blue curve. Okay, so let me summarize. For one cycle, you can have one point is very accurate, no assumption needed. But if you want the whole curve, the blue curve, you need an assumption of C, okay? Which is what we call equivalent static curve. Equivalent static means you treat this blue line as a static curve. You take this blue line, compare with your Kenlich test, compare with the reaction power test. To stop. That is interpretation. Okay? All right, then to summarize, okay, how come? Okay, let me do the clean. Okay, next screen. Okay, so to summarize, right? To summarize, we can measure very accurately the load cell. A is a load cell. We can measure very accurately the displacement. Reflection plate will give us a settlement displacement. And C is an accelerometer. We measure this three accurately. From there, we get, of course, the mass. You calculate A. From A, you get velocity. That's all. All right, and then you have the settlement. So from there, you can plot that graph. You can get one static curve very accurately. With the assumption of C, you can whole curve. So therefore, in short, there are two methods. One is called single cycle. I get this point accurately, and then I assume C. I get this curve. But there's another way to do it. If you do multiple cycle, you drop a small mass, this one accurate. This first cycle with the rapid load test. This is second cycle with the rapid load test. This is third cycle with the rapid load test. And every cycle, 1 point accurate. This blue one is accurate. accurate static value. I don't need the assumption C. I just join this. Engineer were very smart. 3 point, we just joined it up. That's it. So this will give us what we call static equivalent load settlement curve. That's it. And this one replace static test. That's it. So I compare this red line from rapid load test. I get this static equivalent curve and I compare with static. That's it. And in fact, this is equal to static equivalent most of the case. Okay. Now this line represents the static equivalent very well. All right. And by the way, this method is called, this point is called unloading point. And it's not developed by me. It's actually developed by Peter and the Japanese professor Matsumoto many years ago. 89, 86, 87, 89. Okay, so Peter, yes, he's one to come out this together with Professor Matsumoto and plus a few people. So they come out this unloading point, and it's still used today, and it's still well accepted. Okay, now and it worked very well for sandy soil. Okay, but okay, if you have a little bit more clayey, that's what we call the loading rate effect, because you know for sand there's no loading rate, because we are aware that now the test very fast compared with static where you maintain for a long time. That's what we call loading rate effect. But actually this loading rate is only significant in clayey soil, right? Not in sandy. Sand, no problem. So this one for sand and silt, no problem, or rock. That's what we do a lot in Singapore, okay? But if you're clay, no problem. You modify this to call Sheffield method. And look, actually it's like this. This F rapid load test minus MA, except at the bottom you correct with the loading rate parameters. Can be done, okay? And I will advise you on what's the beta value, what's the alpha value, and then you can calculate. Just a bit more complicated. But that's provided you are in stiff clay, okay? So fortunately in Malaysia and Singapore, most of our pond actually is on good sandy ground. I don't need to do this. I'm happy to do this one most of the time. All right, so far, I think we are doing this 99%, doing this 1%. Well, actually, we do have 1 or 2 cases that I need to do this. Okay. I think that's it. Right, just a quick summary. The rapid load test analysis results are unique and person independent. You see, there's no 16 parameters, and you can give an equivalent static curve. This equivalent static curve is simple and straightforward. There's no signal matching required. And based on this, we can get the very good result compared with the real Kenlich static test, which I will show you in a short while. Okay. Okay, the same picture. I want to remind you on this, and I'll break here. Okay. Okay, let's break for 30 seconds again. Can any comment, any particular question on this interpretation related? Is everybody still there? Hello. Everybody still there?
Here.
Still here, clear? Still clear? Henry, still there, clear?
Maybe it's too heavy for us, Professor Chu.
Yes. Okay,
Maybe Professor Chu, you could explain in again the concept is, I think, is not difficult for everybody to understand.
Precisely.
Force, mass times the acceleration.
Yeah.
But the interesting thing is for the stat rapid. For stat rapid, you mentioned that there is minus 20 G with that cushion.
Yeah.
So if you can explain that one more time.
Okay, you see, I have a cushion. This is a pile. This is on the ground. I put a special cushion here. Okay, I have a drop mass. This thing will drop onto it. So this cushion will basically have to compress like this, isn't it? Will come to a stop. This drop mass, okay, change the color. This drop mass here have to come here and press on that. So you will compress. And this from here to here, you're subject to deceleration. you are subject to deceleration. For example, you have a spring. You put a spring there, you put a load inside, the spring will compress and then stop and then bounce, isn't it? So that spring, when you compress, the mass will start from big velocity, go to stop there and then bounce back. Also, obviously, there's a deceleration because velocity come from big velocity when it hit and then come to stop and then bounce back. So therefore, there's a deceleration. Now, if you ask me, Dr. Chu, can you measure this? Yes. The answer is yes, but don't need. Why? Hey, frankly speaking, I don't care. Why? I put the load cell here.
Load cell.
Put a load cell here. I put a load cell here. This is a load cell. Then I measure. I put a 1,000 ton here. To be honest, I put a 50 tons here. I put a 50 ton mass here. If I put a timber cushion, let's say, I put a load cell that I measure 50 ton force only, roughly. But I put this special cushion, if it work, it measure 1,000 ton. Right, so that is a magic. That is a magic. But of course, you ask me, hey, can you give it a formula for this cushion? Well, too bad. You had to ask Peter. That's his company secret.
Well, basically the drop is gravity, just the same as PTA, right? So
yes.
5% to 10% of the load, and you just drop it by gravity, and then the cushion make the
yes, correct. To be accurate, the velocity here is 2gh square root, right? That's what m cancel off to. That's the velocity at this moment. But you come to here, you got the velocity is 0. So how to reduce from here to here? How to design that cushion? That is tricky. That's tricky. But let me, to be honest, I work with Peter and myself for 20 years. Concept is what? But how to make the machine so neat and so nice? Honestly, not easy, to be honest. And then you should salute the ornament people. Really make that nice machine, to be honest with you. I mean, for whoever want to think that, hey, I can make myself, go ahead. But to make the machine really fit well, actually not as easy as you think. But anyway, that's the concept. Good, you asked a sharp question, Ryan. Okay, all right. So let me continue.
Professor Chu.
Yes.
Yeah, I have some question. The cushion used the principle of a spring, right?
Repeat, principle of?
The cushion used the principle of a spring.
A spring, yes.
Yes, spring. As we know that the spring will relax off the time. Is there some kind of calibration that needs to be done?
Yes, very good question. That question, I'm not going to answer here. That question tell you need good company, constantly calibrate the spring to produce good result for you. Full stop. But you're right. You are right. The spring, if you load it many times, the constant will change. Then the result will be different. So that's what I'm trying to say. Concept is there, but anybody think that I can make you can do yourself, go ahead. It's not as easy. Yeah, but you're right. So sorry that I can only answer you this. The spring need to be, the property need to be constant, properly calibrated. That will give you the force that you want. But as engineers, this leave it to the ornament. They have to do it properly. But as far as I'm concerned, I only look at the force I measure. I look at the force I measure. I want the force to be this number. You must produce this force for me. That's it. Okay? Can I answer you this way?
We have question from Pak Amin Sundoro. You raise hand.
Yep.
Silakan,
yeah. Mr. Chu, can I ask something?
Yep.
By the way, how much does it cost? Is it cheaper than Cambridge or more expensive than PTA?
Okay, good question. Anything related to money, I am a technical advisor to Ornamic. I do not know anything about the money, okay? But to be honest with you, in Singapore, the price is very competitive with static load test, okay? But of course, I know the different country, the static load test price can be very different, okay? But definitely it's more expensive than PDA because PDA is too simple and PDA. But you don't forget the objective. This test is to replace static. It's not to replace PDA. I don't care about PDA. In fact, in Singapore, maybe I should expand this a little bit. In Singapore and Malaysia, we do not accept PDA to give us the static load settlement curve. No. Although PDA can give it this curve, but it's not valid. We only use PDA as QA, QC for power quality, like PIT, but more advanced PIT. You know my point? So we don't, unless you are steel pipe power, so sometimes we do. But in general, for ball power, we are not accepting PDA. So, okay, anyway, as far as money is concerned, yes, that's out of my jurisdiction. I don't care. But I will say that, yes, if you have a lot of tests, let me to be fair to the company, if you have a lot of tests in Indonesia, like what we have in Singapore, put a machine there, actually the price of that is not high. But at the same time, to be honest, you have to think that the value you get is actually, to me, it's just that you buy a better machine, better equipment that tests better than static tests, faster than static tests. You should charge higher. Why are you charging lower? Okay, anyway, this one we leave the discussion to the other meeting, okay? To privately meeting, okay? Yeah. But I can assure you it can be competitive. Not compared with PDA, but compared with static. But of course, I have to say that the static sometimes in different countries will have a different, totally different scale. You have to think about the value of this test. Much faster, very accurate, you get result on the spot. Think of this, you don't mind paying money. Just like you pay good money for good transport system, high-speed rail rather than normal old train, right? You cannot compare the good train versus a slow train. So it's different comparison. Okay. I tell you what, give me another 10 minutes to 15 minutes. I share with something else on the code and correlation quickly, and I'll open the floor for all questions. Okay. Code, I'm going to skip the code a lot just to tell that yes, in Japan, 2002, in Netherlands, even earlier, I don't even know what year. USA, ASTM 2008, Eurocode 2016, all approved. In fact, more. Okay, and Singapore, of course, make use of all this code, we accept it. Malaysia, we accept it. Okay. Now, so this is what we call, I think Wayan also show you this slide that I have, ASTM 7383 208. Of course, there's a subsequent yearly approval, but I forgot to give the later, but it's the same. In fact, I would say ASTM is the one who introduced the word rapid load test, this word. So rapid load test, right? And this name rapid load test come into picture. Now, in ASTM, you read carefully, inside there, 1.2, I even give a section. It provides what we call dynamic, is a combustion gas pressure apparatus, and also cushion drop mass, which is stack rapid in the section 1.1, 1.2.1, 1.2.2. So both methods are accepted in the same standard. So both methods accepted. Okay, and the relative advantage of both or two, we talk about it next time, but both are accepted. Now, of course, in 2016, Eurocode also have it, and Eurocode has a statement somewhere inside here to tell you that whatever test here is equivalent to the static test measure. So that's what the static equivalent come from. Okay, I think I can skip this one. Now, the both code ASTM and Eurocode has a lot of strict requirement on how to conduct rapid load test correctly so that the interpretation can be correct. That's also important. Sorry to say, if anybody buy a hammer and drop, you think that's rapid load test, I'll tell you, will not satisfy ASTM code. So therefore, as I say, concept looks simple, but you want to make the machine work to satisfy, not as easy as you think. Okay, there's a lot of requirement there, but I'm going to skip all except to highlight only one thing, right? Or I will say that the code said that you must measure load, measure displacement, you must measure acceleration, but high-speed PDA does not satisfy this. I just want to say that, okay? But I will skip all this to tell you that the loading requirement is very important. You must produce a load, go up and come back. And this duration based on ASTM must satisfy 12 L over C for the zero load, or 4 L over C. Meaning this time, this duration here, the duration must be, this time must be more than 4 times L over C. L is a power length. C is a compression wave velocity. Okay, in terms of meter per second. So you do this, L can be what, 40 meter to 80 meter, 90 meter, like that. Okay, so the longer the power, you need longer this duration. Now PDA is like this only. Okay, PDA, the duration or time is too short, that not satisfy this. Or it's not only short, it's short a lot by 10 times, that kind of thing. Okay. So therefore, you have to understand that. Now, again, as I say, so this time has to be 10 times over C. Of course, the longer it is, the better it is. So that's the reason is that is so that the wave will travel up and down many times. So therefore, this rapid load test, the wave compression is not important. PDA is here. Can you see only one time or less than one time? So therefore, the wave propagation effect is important. So therefore, you need to do signal matching. But whether rapid load test, I don't need. Right? It becomes a rigid body movement, things like that. Okay, so I think that's about all that I want to cover for this due to time constraint. I just want to have one word to say that if you want to do instrumental power, meaning you measure the power shaft resistance, so you put strain gauges along the power shaft, you do the same thing. The only thing in the type of strain gauges, you have to use what we call, we cannot use vibrating wire, but you must use the resistant type strain gauges, which is the old method and established. To be honest, I'm sure today, all the old professor on powering your research is done on this. Vibrating wire is a new one, which is good, except the vibrating wire, you take the reading at 1 hertz. 1 hertz means 1 data per second. Now you remember, my whole cycle test, typically from here to here is 200 millisecond, 0.2 second. You understand my point or not? So in 0.2 second, the test over. So I need a lot of data. I need a lot of data point. But if you do straight what is that? The vibrating wire, you have 1 point, you have 1 data here. Next data is here. I mean, it's over. You know my point? You cannot capture this curve. But don't worry, you just use the old traditional resistance type strain gauges, which is in the market for 70 years. All right, it's perfect. Okay, so I just want to remind you on that. Okay, now last but not least, what I want to share is to prove to you that this is compared very well with static. Okay, so I'm going to show you a few slides. This is very important so that you're confident. Okay, so I'm going to show you a few jobs that I can skip this introduction. Okay, I skip this introduction. I skip all this. I skip this one. I just want to show you correlation of dynamic versus static test in Malaysia with different power, even different power diameter. But for different power diameter, you must normalize it with the diameter. So you can see that we have done 2 tests, or many. I just show you one. One case that the power length and then load is different, and then settlement, we conduct that, and then we get the test. This is a dynamic test, and then this is a soil data. We can skip. This is a test result. This is static test. This is dynamic. And again, it's 1 point accurate, this one with the C assumption of C. But still not too bad. So now you put the static, right? And then you put the 2 together. Unfortunately, they are different diameter, but you correlated it. That's what you get. One is static, one is dynamic. But of course, dynamic have to go to unloading point method, go to static equivalent. When I tell you rapid load test means rapid load test, go through the unloading point method, then get the static equivalent, which is this red curve. You see, the comparison is very good. For geotechnical engineering, this is like few mm. Okay, good. This is big power in Malaysia. Now in Singapore, we do a lot more powers in just now was dynamic. Now we do a lot in stack rapid in Singapore. You can see this one. We have again many hundred. But let me just highlight the number to you here. Okay, sorry, I want to highlight 2 numbers. So this one, you can see this is the stack rapid method. We just look at the last one. 3 times working load, 21 mm. And you look at the other one. You look at, I'm moving away this, 19 mm. Static. Sorry. So this one you convert, you get static equal to 19. So I should ignore this one. So this is rapid load test, stack rapid test, but after getting static equivalent 19.63, and this is static load test by Kenlich method, 19.63. But this is coincidentally exactly equal. Okay, but I can see how good is a match. And look at this. This one is the instrumented. So we load the load transfer. We can measure load transfer curve. At one particular load, this is red is static, one is dynamic. See, perfect match. See, one is static, this is static. Static means a cartilage, huh? This is cartilage. And this is a rapid load test. Again, let me repeat, rapid load test, then do unloading point method, and then get this so-called equivalent, okay? You compare, you see, hey, you may say, hey, not exactly, but look, this is only few mm, this is only 2-3 mm things. You see, so it's very close. And then you look at the exact number, actually it's almost matching. There's one, second one, can you see the two curve? Right, and this is 5 mm, from here to here is 5 mm. So you can see this is static and rapid load test very close. And look at the number again. This is, which one is static? This is sediment of static, cartilage. Cartilage average is 19.96 and rapid load test is 18. This is more, I like this one. Different by 1 to 2 mm. That is more correct. I like this one. Just on the one is exceptionally accurate. But a lot of time we get 1-2 mm different, which geotechnically is perfect. Okay. Now let me show you, right, more result by Ricky Nagati. I show him because he's a director HDB, and more important, he is Indonesian. Hey, he's my good student. He's my student NUS, and he works for government HDB now. And he wrote the paper with me, right? And we just presented in a conference last year in Rotterdam, correlating rapid and static load test result in Singapore. And look at the result. We have done many tests, compare cartilage, and we do the cartilage first, then do stack rapid. We also do stack rapid first, do cartilage on the same pile of different type of soil. The detail I'll show you next time if you want, but this is the result. This is settlement for rapid load test. This is a settlement for static load test. And this is 1-to-1. Hey, you can see, Dr. Chu, it's not on there, it's different. Hey, but look, this is 1 mm. So at the most, this is what? Less than 2 mm different. Let me repeat. This is 1-to-1, perfect match. If all the result on perfect match, I tell you, that's cheating. In geotechnical engineering, if you match 1-to-1, it's cheating. But you see, all my data is different by not more than 2 mm between the two tests at one particular load. In this case, it's 1-time working load. If you get 2-time working load, can you see? All these are good except this point. This again 5 mm. So this about again 2 mm. This one a bit big. That is because I did not take into account the so-called second cycle effect, which is what I call virgin over residual, so which I'll explain next time. But if you take that into account, see, same data. These two are the same data, huh? 2-time working load. I put it to 3 times. You can see the biggest difference here is this is 5 mm. So this one is obviously 2 to 3 mm. In fact, less than 3 mm different. You see the point? So let me repeat. So in Singapore, Malaysia, most of the tests that we get, correlation can be as good as settlement within 2-3 mm when you test up to 2-3 times of working load. And that is what we're interested. That's what your high-rise building are interested. Okay, of course, you can compare the ultimate load, but in Singapore, Malaysia, we like to compare the settlement at 2-time working load because that is important for your proof load test rather than ultimate load test. Finally, on productivity, I can skip all this. I just want to show you this is a big project in Singapore. Skip. Just see the last number. Okay, wait, where's my? I want to move this board away. Hey. Okay, this. Okay. Important one is normal cartilage test takes 16 days because in Singapore, because you got to transport all the block 16 days and this one 3.5 days. Like rapid. Next project. Next project is a big part. Can you see? I test 4,000 tons. It's a big barrett part, which is for the MRT. MRT is our mass rapid transit, like your subway, light rail piers. It's similar to your power bridge pier, that kind of thing. Big power, big diameter, big power, big load, and we test and location. You see, cartilage you need this high, but dynamic only this high, this much. Okay, and then the footprint number can skip this one. Hey, because that's a super big. So therefore, the conveyor can need 9.2 months. And I need 4 days, 3.5 to 4. No matter how big, how small, 3.4, 4 days. Okay, that's the beauty. Of course, to be fair, transporting from Singapore equipment or Malaysia to Indonesia, separate day. Professor Wayan, you cannot say, hey, Dr. Chiu, you said 3 days. You ship the thing in 3 days. No. Shipping excluded. When you're in the port, you go there 3 days. Okay, perfect. And in fact, HDB has analyzed this number. Of course, this is in Singapore. Typically, static cannage test take 80% reduction in productivity, reduction in manpower and time in manpower, and overall land is 85%. So overall productivity is very good. That's all. Okay. Yeah. And wow, we love to look at all these things, manpower, man hour need, things like that. So we save a lot. Okay, I think that's it. I just want to end with a summary, conclusion, 3 sentences. Okay, let me breathe in. All right, number 1, the load settlement behavior of the test pass subject to static load and rapid load are very similar, so therefore correlate very well. Correlation between 2 tests, rapid load test and static load test, are found to be excellent in terms of specific settlement value or specific load settlement response, which are most of the time we want, load transfer curve, mobilized skin friction, mobilized end bearing, compared with static. They're very equal. They're almost identical most of the time, provided you do it properly. Provided your spring, I think, who was there to ask? Adib, right? You asked a question. The spring must be properly calibrated, conducted properly, proper equipment. You get very good result. So finally, a safe, productive, and easy to use device become available, which allow power tests to be performed economically and reliably, and what's the last word? Beautifully. Maybe that beautiful word should end my lecture today. Okay. Now it's 5:50, sharp, 6:50, perfect. 4:50. Okay, thank you. That's all my lectures.
4:50.
Yep, perfect.
Okay,
now,
thank you, Professor Chu,
thank
for
you.
your explanation, presentation.
Yeah.
And we still have time, maybe not much. If you have some question, Bapak Ibu, kalau ada pertanyaan, silahkan untuk ditanyakan Bapak Ibu. Profesor Show ini lebih ke sisi teknis ya, untuk sisi bisnis perusahaan, vendor dan semacamnya mungkin bukan ke Profesor Chow, tapi mungkin nanti ada perusahaan yang akan memperkenalkan juga nih Pak. Saya belum tahu juga Pak Heri, mungkin nanti bisa ada informasi Bapak. Silakan Bapak Ibu kalau ada pertanyaan.
Satu Pak Adib, kalau bisa Pak Adib. Pak
Ya,
Tianto.
Silakan Pak Tianto.
Thank you, Prof. Chu. I'm sorry, I'm in Indonesia because my English is not too fluently, bad in English ya.
No, I hear you clear, sharp.
Oh no. Please Pak Adib, tolong sampaikan Pak Adib. Kita masih agak mungkin harus memang ke sana ya arahnya ya, tapi kan perlu waktu. Ingin menanyakan ke Profesor Chu, Pak Adib nanti punya nggak experiences dari Pak Chu itu tentang bagaimana kita menggaransi bahwa keakuratan dari alat ini ya, kegagalan atau value dari suatu hasil gitu ya, itu apakah kegagalan itu memang kegagalan di pondasi atau kegagalan dari alat itu siapa yang mohon supervisi ya. Kita butuh ini sih garansi benar dari perusahaan bahwa sistemnya benar-benar akurat gitu ya, sehingga kalau ada suatu kelemahan itu memang itu benar-benar filenya yang lemah di dalam kapasitasnya. Itu mungkin ada pengalaman kegagalan itu pada Pak Chu, bisa ditanyakan Pak Adib. Terima kasih Pak Adib.
Baik, terima kasih Professor Chu. The question from Pak Tianto is, how do we guarantee the accuracy of this tool? If the result is failed, is it the file that failed or the tool that failed? How to guarantee if the result is failed?
That's a very good question. In fact, your question itself answer for it. Meaning that if the result is no good, there are 2 possibilities. One is the test is lousy.
Yeah, not fail, but not good. Yeah.
But the second one is the part itself is no good. Yeah. In fact, I was telling you a joke. In Singapore, I don't quote the man. One very high official in government authority. He tell me one sentence. He said he was in. He's the government authority who control. I mean, he have all this power result. He said that for the last 20 years, he never see a single PDA result that show the power failed.
Oh.
Contractor always submit the PDA result that pass. But I will tell you that for stack rapid test, actually we do have a few cases. The result no good. No good means the power plunge. And later we do a check. Is a power structural failure or geotechnical failure? Yes, we do have that. So in fact, well, good point that you mentioned that. I remember just I mentioned about the paper we present in Rotterdam last September conference. I wrote another paper on the shape of the rapid load test curve. From the shape, I can tell you a power fail or not. And then with that, we check. So in that paper, I highlighted a few real case study where people run PDA test, cannot detect, but run the rapid load test, we tell them, look, the power problem. Right? You have soft toe problem, or you have a structural gap, the power can crack in between. The rapid load test will pick up. And in fact, for a few jobs, we do the calling to prove what we say is correct. So in short, yes, I will answer you that rapid load test will be able to detect if the power fail, really fail. Because, let me have one more sentence. Because you put the real load on it, 1,000 tons. The PDA only put a few tons only. That's the main difference. I hope next time I'll show you the real data, but take my word, we can show.
Thank you, Mr. Chu.
Welcome. Good.
Bapak Ibu, yang lain silakan.
Excuse me.
Silakan Kak Putra.
Mungkin saya Putra dari Kementerian PUPR, Direktorat Jenderal Perumahan. I'm Putra from Minister of Public of Work. Maybe I want to know about what kind of type foundation can be test by the rapid load test method, this one, and how many times I need to test for the get good result to the test. Okay, thank you, Mr. Chi.
Good. I answer. Good question. What type of foundation you can do? Power foundation for building, power foundation for bridges. Even a power if it's in the water. Remember, you build a bridge, some of the power will be in the water. Even that is very good to use stack rapid or stack dynamic to do the test. Okay, and you can do that. So any power foundation, you can do it. Okay, now the second question is, how many times you have to do the load? Now, stack dynamic, because stack dynamic has this fuel, you blow it one time, it's a bit difficult to take down and put it again. So normally we do one time, boom, test. You get 1 point accurate, the rest of point, you assume some C, get to be not too bad. I will say this honestly, this, okay? So that's one time. But the stack rapid, the cushion one, for the same ball, you set up, see my hand, like this, boom, one time. 10 minutes later, boom, second time. Then 10 minutes later, go up, boom, third time. Go up, boom, fourth time. I can do 4 times. 3 times to 4 times. Good enough. But must be from small to big, But I say, hey, what if I test 10 times? You can go ahead, but don't need. So you need only 3-4 times to get a good result. Good or not good result, let me stress one more time, like what Adib have said, Putra. Good equipment, good spring, proper conduct is very important. If you have all these 3, you don't need to repeat the test. So far in Singapore, I don't think we never have to repeat the test. Every test result come up very good, consistent. Yeah. I hope that answer.
Thank you.
Professor Chu.
Yes.
Silakan Bapak Ibu lain.
I want to ask you about could we use the best operator, skill operator or not?
Operator, is it important? Yeah. Setting up is important. The operator, the automatic machine, everything automated. If it's set up properly, the engineers is going to look at the screen. Okay, I didn't show you because this one, it could be the real project. I'm sure the Ornamic will bring the equipment and show it to you. Everything connect to a PC computer. You see every data on computer. Remember, just I tell you, the thing must be balanced, must be set perfectly. So all the tilting number on the computer, every night, just press the button, start, boom, on the test. So operator, I will say, is a setting up that's very important. You need the right company, the right equipment to set up properly. To run the test, it's different from PDA. You need the people live up or whatever. No, this one is everything connected up. Press a button. Everything. Marcel, you want to add on that? Everything automated. Yeah.
How many samples we need for
how
testing?
How
many person? How many percent
how many person you need?
The pile. How many percent of the pile
Must you
we
test?
need?
Oh,
Test, yes.
That's not for me to answer. That's for Professor Wayan and for Harry in your committee. In Singapore, we test 1% of the pile as a working load test, meaning that if you have 100 piles or if you have 300 piles, I must test 3 piles as a working load, means test up to 1.5 or 2 times working load. So now in Singapore, all these 3 piles, I don't have to do cannage. All the working load, I can use rapid load test. After you calibrate, you can do rapid load test in Singapore. Now, if you do ultimate normally is 1 per block. Singapore, we do 1% of the pile. Yeah.
I mean,
I should say, wait.
in Indonesia.
I should say this, wait. Professor Wayan, just one more. But for bridge piers, for LRT, all this, every pier we test 1. Imagine you have the bridge. The bridge has 2 piers. This pier have only 3 piles. These 3 piles, at least 1 must test. This side 3 piles, at least 1 must test. Because the bridge is so important. so that one cannot go with the percentage. Go with every pier you will test. Yeah, Professor Wayan.
Yeah, for Indonesia, Pak Peter, as I mentioned, yang seperti yang saya bilang di awal itu, kalau kita secara umum di SNI Geoteknik kita mensyaratkan itu 1%, 1,3% untuk bore pile, kemudian 1%, 1% for the driven pile. So that is general requirement. But for bridge, there is no exact, no clear, requirement. But that general requirement is maintained for, various for building, for bridges and others. No.
For bridges, the number of power definitely less. So, but the percentage will be very. I mean, like I say, you definitely have to test 1 per pier.
Per pier,
yes.
That sound reasonable, because like building in one area we have 1% or 1.3%, but for bridge you have a lot of pier that spread, so the uncertainty there is higher compared to the footprint of a building, right?
Yes, definitely.
Excuse me.
Ali?
Yeah, my name is
Ali.
From the Directorate of Bridge Construction. Thank you, Prof. Xu, for the lecture. I have a question for you. How about the huge force that coming suddenly struck the top of pile? Yes. For example, made from concrete. Is this method more damaging to the top of pile rather than a static pile, which is using gradually load?
Good question. Ali, you must be a very few people. Good question. The straight answer is, therefore, proper design, proper company is important. You know why we do 20 times, don't do 40 times? Because F equal to MA, I can make the A equal to 40 times G. No, you see, so therefore, the reason we do that 20 or sometimes 22, 25 or 15 times, so that we have to check the maximum load applied on the pile cannot be more than the structural capacity of the pile. So you're right. So if your pile is concrete of grade 35, meaning the compressive strength is 35 MPa, the load that we apply cannot be more than 35 MPa. But It's safe. You know why not? Because remember your design is the ultimate load divided by cross-sectional area that has to be less than your concrete compressive strength. So if I test working load, 2 times working load, it's definitely less than ultimate. I divide by the cross-section will be less than your compressive strength. Will be less. Okay, but you asked a very good question. To be honest with you, this is a secret. This is a secret. Actually, we can measure based on the signal we receive, based on the acceleration. Actually, we can calculate what is the maximum load that experienced in a power. If that exceeded your compressive strength, the power will fail. In fact, that was one of the failure I can predict. So my answer to short, if proper design, 2 times working load, full load acting on a power cross-section should be less than your compressive strength. Stop. So 99.9% time, no problem. If we measure the force is bigger, that means your concrete got problem. Concrete got problem. So it exceeded, it failed. Indeed, I told you, right? PDA will not be able to pick up this, and we can pick up. In fact, in Singapore, we pick up 2 times exactly like this. Out of few hundred. Yes. So don't worry. Yeah. It's the contractor to worry. If the contractor use lousy concrete, you're worried.
I get the point. Thank you, Prof. Shu.
Good.
Sudah jelas. Baik, pertanyaan berikutnya kita mungkin sampai 5:10 ya, Bapak Ibu, kalau ada pertanyaan atau diskusi. Maybe we have discussion until 5 to 10, Prof. Shu.
Until 10 midnight, yeah, correct. I'm happy. I love that lecture. People stay back, but of course cannot go too long. Okay, now you control. Yeah, Chairman, you can control.
10 minutes after 5 minutes.
Yeah. Yeah. Maybe we can take the last questions. Yeah.
Yes, last question maybe.
Yeah. Don't worry, if you guys have a lot of questions, you just tell Henry and tell Professor Wayan that you love to see me. I love to come to Jakarta and face-to-face, and we work on the project. I mean, if you have a project, I'll come, and then we discuss.
Pak Sarkowi, ada pertanyaan, Bapak?
Nah, saya yang tanya tuh.
Ya, benar.
Oh, Pak Henry. Silakan, Bapak.
Yeah, because my device no unmute button, yeah. So I would like to ask you about the possibility to use with the variation of the diameter of pile, bore pile. In case of the IKN, yes, it's only one single diameter, 1.5. If we have many, then this device can be applied simple or many kind of the diameter. Thank you.
Good question. Good question. I think that's a good question to end. In principle, you can test this rapid load test for any diameter of piles. Okay. In Singapore, building control authority has a bit of strict control. In Singapore, even static load test, static load test. If the whole site has some piles 800 mm, some piles 1,000, you can test either one. Mean 800, 1,000. That's it. Fine. 1 meter. Fine. But if you have a pile is 800 mm, you have some pile 1,000, you have some pile 1,002, some pile 1,005 meter diameter. Okay. In Singapore, BCA government will require you to test 1 pile on, 1% on 800 to 1,000, 1% on 1,002 to 1,005. You see what I'm trying to say? Meaning that you test on 1,002 can represent 1,005. Test on 800 can represent 1,000, but test on 800 cannot represent 1,005. Okay, that's in Singapore. But I show you the result in Malaysia that we need. Actually, that's what my proposal, and we did it, and we wrote in the paper. Actually, we found out that if you calibrate with the normalized diameter and normalized working load, actually, the test result can be equivalent. But that is within, I will say, that's still within maybe 800 to 1,005. If you want to represent direct power, big one, 2,005 meter, 2.5 meter, or 2.8 times 1.8, big power. I think to be fair, you better test two size. You understand my point? And there's nothing to rapid load test. There's more, even static, you have to do this. Let me repeat. In static, if your pile is too wide range, you need to test 2 or 3, one small, one big. You understand my point?
Yes.
Although I show you the paper in Malaysia that, in fact, if you normalize the diameter, normal working load, actually it's equal. It's almost equal if you normalize it. But that is still within certain range. That's what I should say.
Thank you, Joe. Thank you, Pak Wayan.
This is a very good question. This is very practical and important question. So that deal with the actual project. So if the actual project have too big the power range, then we have to sit down and decide what type of power we should test. Okay, good.
Okay, baik. Thank you, Prof. Chu. Bapak Ibu masih ada pertanyaan atau kita akhiri? Silahkan kalau masih ada. Jadi stat dynamic dan stat rapid itu metode pengujian non destruktif untuk mengukur respon yang pancang terhadap beban yang cepat.
Apa ya?
Dan kalau stat dynamic metode pengujiannya menggunakan dongkrak hidrolik untuk menerapkan beban dinamis ke yang pancang. Professor Chu, could you share your presentation maybe to us?
Yeah, I will do it. I will send it to Professor Wayan and who it is Henry. Yeah, I will make a PDF. Okay. Yeah.
Okay, thank you. Oke, Bapak Ibu, mungkin kita akhiri. Prof. Chu, mungkin we finish our discussion. Or we finish, we have closing from Mr. Atianto. He is the Secretary General of IRDA DKI Jakarta. Please, Pak Atianto, we welcome your speech.
Baik, Bapak Ibu sekalian. Bapak Ibu sekalian, mohon izin kami di-download untuk menutup webinar kali ini. Jadi memang di IKN sekarang ini sudah hampir 1 juta file ya Bapak Ibu sekalian. Jadi membutuhkan suatu cara, metode tes yang benar-benar lebih efisien, efektif, ya lebih tadi Pak Profesor Chu mengatakan lebih economical lagi, beautiful lagi gitu ya. Jadi mungkin mau tidak mau kita harus ke sana, tetapi masih harus ada jalan yang harus kita tempuh ya, benar-benar secara secara penjajakan teknologi ini harus segera dimasukkan di dalam spesifikasi dulu. Ada tes-tes yang harus kita kita laksanakan, tantangan buat kita semua sehingga secepatnya bisa diaplikasikan di Indonesia. Thank you. Allow me to deliver the closing speech for this webinar. Honorable Professor Chu, the Assistant Professor in Department of Civil Engineering, National University of Singapore, yang terhormat Profesor Insinyur Dr. Insinyur Wayan Sengara, PhD, Guru Besar di Fakultas Teknik Sipil dan Lingkungan Geotechnical Expert, Institut Teknologi Bandung, Dr. Heri Fasa, Ketua DPD HBCI DKI Jakarta, sekaligus Ketua Satgas IKN Bina Marga, kemudian Bapak Ibu semuanya, moderator Pak Adib, terima kasih dari Bintek Catatan Bina Marga, and all participants in this webinar, ladies and gentlemen, I would like to express my sincere gratitude to everyone who has joined us today for this insightful webinar on stat rapid and stat dynamic testing methods for pile foundation design. We hope that this webinar has provided you with a valuable insight into the latest developments and best practices in dynamic pile load testing. Stat rapid and stat dynamic are two types of the dynamic pile load testing methods used in geotechnical engineering to determine the load capacity and performance of piles. Stat rapid is a non-destructive testing method used to measure the pile's response to a rapid impact load. In this method, a heavy weight is dropped into the pile from predetermined height, and the resulting acceleration and displacements are measured using accelerometers and displacement sensor. The measurements are then used to determine the pile load capacity and other performance characteristics. Stacknomic is a more advanced and sophisticated testing method that uses a hydraulic jack to apply a dynamic load to the pile. The load is applied gradually over a short period, and the resulting displacement and stress are measured using high-precision sensor. The measurements are then analyzed and determine the pile load capacity, stiffness, and other performance characteristics. Stacknomic testing is more expensive than StatRapid, but is more accurate and can be used to test larger piles. Both StatRapid and Stacknomic testing methods are useful for determining the performance and load capacity of piles, and their results are often used to optimize the design and construction on pile conditions. As we have seen, both StatRapid and Stacknomic testing methods offer unique advantages in determining the performance and load capacity of piles, and their results are often used in optimize the design and construction of pile foundations. By understanding the key differences between the two methods and their respective applications, geotechnical engineers and construction professionals can make informed decisions about the most appropriate testing method for the given project. We hope that the information shared in this webinar will prove beneficial to you and your future projects. We encourage you to continue learning and exploring the latest trends and best practices in geotechnical engineering as the field continues to evolve and advance. Overall, in the future, we expect that dynamic pile load testing methods will continue to play a critical role in geotechnical engineering, providing value insight into the load capacity and performance of piles by embracing new technologies, automating testing procedure, integrating with BIM, building information modeling, and promoting standardizations. The future of dynamic pile load testing method is bright, and they will continue to evolve and improve in the years to come. Once again, thank you for joining us, and we wish you all the best in future endeavors. Thank you, everyone.
Thank you, Mr. Adianto.
Waalaikumsalam.
Thank you, Professor
Thank you,
Chu.
Prof. Chu.
Thank you, Pak Busher.
Thank you,
Wayan
Prof.
Negara.
Ya,
Terima
we
kasih.
commit
Bapak
soon.
Ibu, terima kasih atas kehadirannya. Izin ditutup. Bila itu wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi taala wabarakatuh.
Waalaikumsalam
Terima
warahmatullahi
kasih Pak.
Terima
kasih Pak Adianto.
Terima kasih Pak Adianto.
Oke, izin
Terima
live.
kasih Pak Sailan.
Ayo sama.